Hi, I'm Richard Hinke, and this is my sharing video 2, and we'll be talking about safe parallel processing. So to talk a little bit about safe parallel processing, we have to talk about threads. And what threads are, defined by Oracle, is it's an object that allows us to have multiple threads of execution running concurrently, or in other words, at the same time. Each application, it has a main thread that executes a stack of instructions. Think of each thread as being like a separate person on a team. Each person may work on the team project at the same time as the other teammates so that the project can be completed faster. Each thread, or person in our example, has its own thread stack. Now, the other thing that we have to talk about are runnables. Now, you're going to see when you look into threads quite a bit that runnables and threads are going to be used all the time together. And the reason is a runnable is an object that has a run method containing the stack that the thread wants to run. So a runnable, according to Headfirst Java, a runnable is to a thread what a job is to a worker. So the runnable is the job. It's the data or the job that we want to perform in our application. And the runnable object must be passed to a thread so that the thread may access the job that it needs to perform. And there are three main states for a runnable object. You have it in either state, a state of runnable, running, or blocked. The other thing that we have going on here is a thread scheduler, and this controls which thread gets to take the floor and to be the active thread. Not all schedulers will work the same on every machine, though, so we can't rely on them always processing everything equally. In other words, the scheduler isn't going to give every single thread the same amount of time to do whatever tasks it needs to. And so that's where we're going to utilize the sleep method of the thread to allow our threads time to each have their own turn. Otherwise, a thread will just hog up all of the time until it's completely finished with everything that it has saved in its stack. So let's actually take a look at the example code that I have, that I've been working on. Okay, so let me give you a little bit of a tour of this code first. So what I did here is I created a runnable class. So this is going to be, in that example I was talking about earlier, this is going to be our job, what we want to happen. I also created, in here I just made a little bank account class, and it's just going to have a balance of $100. It's going to have a getter and then a setter. Excuse me. We're going to have a getter and then a setter, and then this is just going to return the balance. So I was just looking at my notes there for a minute. So what we have going on here is this is going to be our main method. So you can kind of think about this as being our main. It's not really a thread, but this is going to be the main class that we're running, and so you might kind of want to think of that as being the main thread that's going to be going on here. And what I'm going to do here is we're going to create an instance of this runnable, and then we're going to create two threads and pass them the job that we want them to perform. And when this this job that I'm talking about, this runnable job, when it's started, when we start the threads, it's going to run this method right here, and it's going to do these tasks. So when we're talking about the job, this is what we're talking about doing right here. So after we create these two threads, we're going to name them, and I named one Chandler and the other one Monica. Now, in this little demo, we'll just pretend that Chandler and Monica are married and that they are trying to access their bank account, sometimes at opposite times, sometimes at the same time. And we're going to look at how threads work together and how to safely run them so that they don't end up taking out or withdrawing more than they actually have in their bank account and so forth. So when we create an instance of a thread, it's just an object, and it's not really threading or running until we actually start it. So right here, we're going to start our thread, and then we're going to start our second thread. Now, when we start our first thread, what's going to happen here is it's going to take this job that we passed it and run what we saved in here. So the first thing we're going to do is make a call to our class or our method and make a withdrawal. So to make a withdrawal, we're just going to check and make sure that the balance is greater than the amount that they want to withdraw. And then we're just going to have some little messages printed out to kind of help us keep track of things. And then what we're going to do is put whichever thread is calling this method to sleep for half a second. Anytime we use the sleep method of a thread, we're going to have to surround it in this try catch block because it's going to throw a interrupted exception error. And so we have to catch that error right here. And we're just going to print it to the stack trace. So after that's completed, we're going to print out another little message, again, just to kind of let us know where we're at with things. And then we're going to actually withdraw the amount. After we've withdrawn, again, another little message to let us know where we're at. And if the account balance is actually less than the amount that either Chandler or Monica is going to withdraw, it's going to print out that there's not enough money for, and then whichever thread was trying to access it. This right here is how you're going to get the thread's name. And again, we just named them up here. And that's how you name them, is just set name, whatever you want to call it. So then inside of our job, after they make their withdraw, then we're going to check and see if the balance is less than 0. And if it is, we're going to print out that they've overdrawn. And I'll explain how that can happen when we get to that part. But for now, that's kind of where we're at. And then I'm going to also call just another little method called make a deposit, and they're just going to deposit $1, which I'll explain why we do that here in a little bit too. And then we'll just print out the balance as it is. So let's go ahead and run this so you can see what's going on here. Okay, so we have Chandler, he's withdrawing, and then we're putting that thread to sleep. And while he's sleeping, Monica withdraws, and then Monica goes to sleep. Chandler wakes up, Monica wakes up, Chandler completes his withdrawal, Monica completes her withdrawal. So you can see these threads, even though up here we're starting one and then we're starting the second one. And normally when you program, things are done procedurally, meaning one step at a time. But when we start using threads, they can actually work concurrently, which means at the same time. So that's why a lot of these steps kind of seem like they're working out of step from each other. But what ends up happening is while let's see, so while we've got, so Monica goes to sleep before she actually makes her withdrawal, and Chandler wakes up and completes his withdrawal. And so as we get down here, we're going to see that the next time one of them tries to complete their withdrawal, you'll see that I guess what's the best way to explain this? So what ends up happening here is because they're both running simultaneously, and because they're sleeping in between this message where we print out they're going to sleep and the time that they actually make their withdrawal, which is down here, the other one can actually access this make withdrawal method. And in a lot of cases, they will both end up withdrawing an amount before that amount is actually saved back into the balance again. And so that's how we end up with these. That's how we end up with these guys overdrawing their money. So now I'm going to show you another example of how we can safely run our threads together so that they're in parallel, or I guess safe parallel. So let's see. So we've got just a couple little changes and something else to talk about. So when we're talking about safe parallel processing, we have to use locks. Now, kind of how locks work is each object that we're using in Java has a lock, and they're usually unlocked for the most part. And it's only when we specify that they're synchronized that tells us, or tells Java, that we're going to have a lock and key, and we're going to be using those each time a method is accessed, or I guess an object is accessed. Let's see here. So the purpose for thread locks arises when two threads are accessing the same methods. Data and data is changing at the same time. So let's consider two people, A and B, where A and B both download a Word document at the same time. They each make changes and edit it differently. Then A decides to upload the file back to where it came from with the changes he made. Next, B decides to upload his file. When B uploads his file, it overwrites all the work that A has done, and it's lost forever. This is where a lock comes in handy. A lock allows only one thread, or in our example, one person, to hold the one and only key to download, change, and then upload the document at a time. In Java, every object has a lock, but for the most part, they are left unlocked, so any thread may access them. In order to use a lock, you must specify the keyword synchronized in front of your method. This is how Java knows that the lock and key will be actively used. One important thing to note is that the key is owned by the object and not the individual method that is locked. Or in other words, even though we place the keyword synchronized in front of a method, it doesn't mean that we can have two synchronized methods in a single object, with each of them owning their own individual key, therefore letting different threads access each of the methods separately at the same time. What it really means is that if a thread holds the key, that is the only key to access any of the synchronized methods contained in that object. In essence, each object has only one key to unlock all of the synchronized methods within it, and it can be held only by one thread at a time. So hopefully that wasn't too confusing, but this is that synchronized keyword that I was talking about, and you can see in our code here, that's the only change that I've made. And so let's go ahead and run this now and see if Monica and Chandler end up withdrawing or overdrawing. So far so good, and no overdraws. Now, one thing that you'll note that is interesting, however, is I only specified that the make withdraw is synchronized. The make deposits I left without any synchronization. Now, the reason I did that is to show that for this synchronized method, only one of the threads is going to be able to access it at a time. But with this one, I'll show you an example where while, say, Monica or Chandler is waiting for the other one to finish making their withdrawal, they go ahead and still make their deposit. So right down here, we've got Monica, and she makes her deposit. And we'll notice that after Chandler's last deposit, our balance is 9. After Monica makes her deposit, our balance is 10. And it was Chandler that wanted to know what the balance was right here. And then we get to Monica again. She checks her balance, and it's 11 for their shared bank account. But you'll notice that down here, so we've got 10, balance is 11. Now suddenly the balance is 13, and then back down to 12. So what happened there is, because I didn't have the make deposit synchronized, or I didn't have the make deposit method locked, they were getting the data out at the same time, changing it, saving it back in there at different times when they printed it. And so this is not safe parallel processing. So an easy way to just fix that is we're just going to make both of them synchronized. So now watch as I do that and we run it. Now if we watch the balance, we'll notice that it's never taken out. So there's 61, they make a withdrawal of $20 and add $1 to it. They'll make another withdrawal of $20 and add $1 to it. Make a withdrawal of $20 and add one more to it. And then from there on out, the balance remains in sequence. And so we don't have to worry about them messing up our system. So that's how the locking works on here. There are a couple flaws with locking, or I guess maybe not flaws, but problems we need to watch out for. And one of them is in deadlocking. So one of the main problems with locks is that a thread will not pick up another key before dropping the key it holds currently. So if you have, say, two objects and two threads, and each thread is holding a key to the other's object, but both threads want to access something in an object that the other thread is holding the key to, neither of them will drop their key before picking up the other one. And so what you have happening here is a deadlock. They can't go any further. They're not going to put their key down, and they're not going to be able to pick up the key from the other thread. So that's something we need to be careful of. One of the other problems with locking can occur when you're using the locks, because again, kind of what's happening here is you're forcing each individual thread to wait in line until it has the key, until the other thread is finished with the key before they can actually take the key and use that method again. So really what's happening is each thread is now waiting in line, and they're not multitasking like they should be. So it ends up slowing our program down a little bit. So we don't want to use very many synchronized methods. In fact, the rule of thumb is use as few as possible, but we need to be wary of which methods are going to make a difference in our application. And those are the ones that we're going to need to add those locks to. So with that, that's safe parallel processing using threads and Runnable, and a little bit about locks and some of the pros and cons to using them. And so thank you for watching, and I hope that was helpful.